Hello everyone. So today we are going to solve today's problem of the day, which is 1262 greatest sum divisible by 3. Okay. So in this we have an array terms. We have to return the maximum sum. Okay, maximum possible sum such that is divisible by 3. Okay. So if a number if a leave that complete array. If a number is there which is if we divide by 3, what are the different scenario? So if a number is there and if we divide by 3, that means either that is divisible, or that means divisible means 3n, or either that is going to leave one remainder, that is 3n plus 1, and another is 3n plus 2. So these three ways are there, either they are going to return one remainder 2 or divisible by 2. Okay, so now we have to find the maximum possible sum. So if we calculate, suppose this one is our array nums. Okay, so what is its total? So if we go for calculate its total, 9 5 14 1 15 8 23. Okay, what is its what is the remainder that it is going to leave? So this is going to leave the remainder of 2. So that means this become 21 plus 2, that means 3n plus 2. Okay, now what should come in our mind, like if in this case if remainder, okay, if remainder is 2. Okay, so we think like if we find a number whose remainder is 2 and we subtract it from our total, that means if we have an array, we are going to calculate the sum of all and we are going to store it in total. Okay, now what we want that we subtract smallest number so that we will get our maximum possible sum, right? So if if the total has a remainder 2, so we are going to find the smallest number whose remainder is 2. Okay, so and then we are going to uh, decrease that from the total simple. Okay, so what if we see in this 5, this is divisible, this leaves remainder 2, this one remainder 1, this is going to leaves remainder 2. So 5 and 8 and smallest is 5. So what we have done, 23 minus what 5, that is 18, which is our answer, and this is correct in this scenario. Now take another example. Okay, so what we can take, similarly 3 3 6 5 1 8 is there. Okay, whose total was 23. Let me now, instead of 5, okay, if we add 1 1, so this become 20. Okay, okay, so how much the sum become? Actually we added 4 1. Okay, so 23 plus 4 27. No, that is total. We don't want 27 26. Okay, so 23 plus 3 26. So this total become 26, right? 9 5 14 15 16 17 18. Okay, 26, which is of form 3 and plus 2. Okay, so now we will again going to find the number which is going to leave the remainder to the smallest number. So in this case also we have 6 and 8, sorry 5 and 8. So this 5 is the smallest, so we think like we are going to decrease 26 minus 5. Okay, which is going to leave us the remainder 21. Okay, sorry, which is going to give us the answer 21. Now but there is one more way. What if we in from 26, if we remove 1 and 1, that means 2 1, so this also become 20, but this become 24. Okay, okay, which is divisible by 3, and this is the maximum sum also. So what we conclude from here? Okay, that if total is leaving the remainder 2, we have two options. Either we find the smallest number, okay, and which leaves remainder 2, and we are going to remove subtract that from total and returning answer. But this has the issue. Why? Because we know if something is of form 3n plus 2, there are two ways we can make it in the form of something of 3 of k. Okay, which is either remove some things like 3p 3p plus k, and this k got cancelled. Okay, and that means this sorry, this 3p plus 2, this 2 get that remainder got cancelled, and we get something's a factor of 3. Okay, one another way, what if something's like 3p plus 1 and another number is 3 uh, q plus 1. Okay, so again this is going to give you somethings of 3. Okay, 3r plus 2. And what is this form? This form is similarly like this one. Okay, this form is similarly like to this one. Okay, so what actually I want to say is like we want to remove these two remainder, and to remove that two remainder, either we can directly find a smallest number which is going to return 2, which is going to give the remainder 2, or we are going to get the two number which is going to get the remainder 1. Okay, okay, now what we do, we will check that whether this number 3n plus 1 or this the sum of these two numbers, which one is smaller. So number which is smaller, we are going to remove, like in this case. Okay, 26 is there, we have removed 5. Okay, so because 5 is the smallest number which is going to leave the remainder 2. What the another things is, 3 people, so the number which are going to give you the remainder 1, that means this one and this one. Okay, so if we see, like what is that sum, 2, and another is 5 which is smallest 2, so we are going to use this. Okay, and get our answer. Clear? Okay, now this is for the remainder 2. If similarly, if remainder 1 is there, so similarly two options is there, either we can remove, okay, remove one. Okay, remove one element which is going to give you the remainder 1, or another option is like we are going to remove two element which is going to give you the remainder of 1. How? 2. How? Like if you see, like 3n is there, okay, see 3k plus 2, and another is 3k plus 2. So what this would combinedly give 3. Okay, let this 3p plus 2 and 3k plus 2. Okay, so this combinedly going to give you 3 of p plus k. Okay, two ways there, either the total is going to leave remainder 1 or 2. So if total is going to leave the remainder 2, so we will find the smallest number which is going to find the remainder 2. Okay, and now we compare that with the two smallest number which is going to give you the remainder 2. Okay, okay, again I'm saying again, uh, if the remainder is 2, total, if the, okay, let's recalculate. Yeah. Okay, let's conclude, if total, so, okay, 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 let's conclude what I have said. If total leaves remainder 2, so what we do, we will calculate the minimum number which is going to give the remainder 2. And another thing is, which we are going to calculate, that means we are going to calculate the two minimum number which are going to give us the remainder 1. Now what we do, we will add this two number, and we already have a number which is going to leave the remainder 2, and there whichever the smaller is there, we are going to uh, remove that from the total. Okay, similarly if the remainder is 1, so again we are going to find the smallest number which is going to find the remainder 1. Okay, this is the first scenario, and another is we are going to find the two number which is going to give you the remainder 2 smallest number. Okay, which is going to give you the remainder 2, so that 2 plus 2, 4 remainder, that means finally 1 remainder would be there. And now we are going to find the minimum of the both, and we are going to subtract it. Okay, if we write the code, then we will become more clear. Okay, so let us write the code. Okay, let it be comment. Okay, so Okay, let declare n, int n equal to nums dot size. Okay, and one more thing what I want to say, like here what are the things while solving, what are the things that came, like sometimes came like minimum number which is going to leave the remainder 1, and two minimum number which is going to leave the remainder 2, and in this in other scenario there was two number which is going to give the remainder 1 and one number. So that means clearly we need four variables. What are that four variable I am going to discuss here. Okay, just calculate total also, so that total equal to 0. Okay, this become total plus equal to, okay, this become total plus equal to nums of I. Now this nums of I, for that we, okay, now we our four variable are int remainder. That means the number which are going to give the remainder 1 r1 first. R1 first means this is the number which is going to leave the remainder 1, and this is the smallest number. So if we see the constant, this is 4 into 10, so we will make this number 4 now 1e5 or 1e6. Okay, now add 1 second. That means this is the second minimum number which is going to leave the remainder 1, which is again 1e6. Okay, now similarly we are going to create two variable for remainder 2. So what this is r2 first number, first smallest number which is going to leave the remainder 2, and this is the first smallest number which is going to give the remainder 2. Okay, now if, okay, nums of I, okay, if nums of I modulus 3 equal to 1, that means if that is if that number is going to give you the remainder 1, what I said, if that number is going to give you the remainder 1, so what are the things is there now. So this is going to change this variable. That means the okay, the how it will going to change. So first if we check if nums of I, if nums of I is less than r1 first, right? Okay, what I check, like if nums of I, that means if this current number is smaller than the r1 first, that means it's smaller than both, because this one is already greater than this one. So what we are going to do, we are going to do r2 second equal to r1 first. Okay, and now we will modify our one r1, sorry, r1 first equal to nums of I, right? Okay, now else if nums of I is less than num r1 slash, okay, r1 dash second. Okay, what this is, okay, in this case the number, that new number was smaller than both. So what we did, we will make the second number to the previously one, and the first number to the new number. What this one means, that means this number should be somewhere in the between or equal to the first number. Why? Because okay, this one is less than second number, that means greater than second number, but it can't be, okay, greater than the first number, because of, because it would not come in the else block. Okay, so what we will do, we will make r1 second equal to nums of I, right? Okay, so this is for the remainder 1. Okay, if we think for remainder 2, when, okay, if, okay, sorry, this else came here. Okay, now if else we can okay write else, or if we do not need else also, simply like okay, if nums of I, if nums of I modulus 3 okay, equal to 2. So now we do the again same things. Okay, what like, so if nums of I, that means the number that is coming which is greater than both, okay, r2 first and sorry, smaller than both r2 first and second, then what we are going to do, sorry, okay, so what we are going to do, r2 second equal to r2 first, and in this one this r2 first become nums of I. Similarly if okay, okay, this become r2, so then this become r2 and this nums of I. Same things there like according like above. Okay, now what about what now, now we will see what is the total. Now if total टोटल मॉडुलस 3 जो है इक्वल टू 1 हो जाए तो हम क्या करेंगे, ओके वी आर जस्ट गोइंग टू रिटर्न ओके, और व्हाट टोटल माइनस min of, because we want maximum answer, min of okay r1 first, r1 first comma r2 first plus r2 second. Okay, right? Okay, so if remainder is 1, then we are going to find the smallest number which is going to find the remainder 1, and the two number which are going to give the remainder to smallest number, and whatever the minimum is there we are going to calculate and return. Okay, similarly uh, if remainder is 2, okay, if remainder is 2, then we are what we are going to r2 first, that means first smallest number which is going to give you the remainder 2, and this one become r1 first and r1 second. Okay, what, because these two are going to leave the remainder 1 1, and by combining they are going to make the remainder 2, so that it helps in cancellation. Okay, so if none of the condition is there, that means by default total uh, total is already divisible by 3, so we can return total. Okay, so let's run. 95. Okay, let's declare this. Okay, okay, what's the issue, line number 29, return total. Okay, this was unintentionally done. So okay, so if we submit, okay, now if we see, okay, what we have done, we have just 4 variable, we do not have any extra space. Okay, now we move we trace, okay, so we go to the each element in the array of single time, so this is big of 1. Okay, big of 1 operation. Now if we see what we did, actually we maintain 4 variable, 2 variable which is going to leave 2 minimum variable, which 4 variable, 2 for the minimum number which are going to return remainder 1, and 2 for the minimum number which are going to return 2. Okay, now according to the need we have used 4. Thank you.